Hi, welcome to Unit 6. This is the first video on triangles. So first in section 6.1 we will have some short introduction about triangles. Then we will move on to the second section that is about the similar figures. And the third section that is 6.3 it is about similarity of triangles. And the fourth section it is about the criteria for similarity of triangles. So we will have our exercise 6.1 here. Here we will have our exercise 6.1 and after 6.3, we will have our exercise 6.2, followed by here we will have our exercise 6.3. So in this video, we will discuss about 6.1. So from your 8th standard and 9th standard, I think you would have got some introduction. You will have some good knowledge about what is meant by a triangle, how many sides it will be, what are the types of triangles, all those things. And in the 8th grade, you would have heard about something called as concurrence of triangles. We call it as concurrency of triangles. So we will discuss what is meant by this concurrency. Take this triangle ABC and DEF. So what we can able to observe here is all these three angles. So this angle A and angle D, they are same. Angle B and angle E are same, and angle C and also angle F are same. Okay. Not only the angles, we can able to observe that the side BC and the side EF are same, and the side AB and the side DE are same, and also the side AC and the side DF are same. So it is same and equal. So we call this one as the concurrent triangle. So the symbol for concurrent is, so this is the symbol for the concurrent triangle. So this is the symbol for the concurrency of a triangle. Okay. So this one already from your ninth standard you would have known. Okay. If two triangles are concurrent, then it will have same shape. It will have same shape. It will have same shape and also same size. Okay. So it should have the so both the shape and also the size has to be same. Then it is called as a concurrent triangle. Okay. For example, let us look at one more example here. So we can able to see it here something like a quadrilateral. There are three quadrilaterals. All these three quadrilaterals are having same shape. All the three quadrilaterals are having the same shape and also the same size also. So this figure, it is a concurrent figure. Okay. Coming to this one, here it is like a trapezium, whereas here it is like a parallelogram. This is like a trapezium. This is like a triangle and this is a hexagon. So this is not a concurrent figure. We cannot accept this as a concurrent figure. Okay. So concurrency means it should have same shape and also the same size. That one we call it as the concurrency. Fine. But for the 10th standard, we are not going to discuss anything about concurrency. We are not going to study anything about the concurrent triangles. We are going to deal with a topic that is called as similarity or similar triangles. That is what we are going to discuss. So we are going to discuss about similar triangles. So the concurrent triangles already you have done in your ninth grade. Here we are going to discuss about similar triangles. So what is the difference between the concurrent and also the similar? Okay. So now we can able to see some four-sided figure here. So there are two figures. One is a smaller one and another one is a larger one. So we can able to observe here there's a number 4 and this side is 4 and this side is 8. So 4 by 8 it is 1 by 2. And coming to this one, this is 1, that is this value. This is 1 and this one is 2. This distance is 2. So it is 1 by 2. So here also we have 1 by 2. Here also we have 1 by 2. Coming to the other side, here we have 5, 10. So again it is 1 by 2. Here we have 6 and 12. Again we have 1 by 2. So what we can able to observe here is this 1 by 2 is constant, or these two figures are at a ratio of 1 is to 2. Or in other words, we can tell that this figure and this figure are similar to each other. It is looking same. So what is mean by similar triangle is it will have same shape. It will have same shape, but not necessarily, the same size. But not necessarily the same size. That means, what is the meaning of this is, it will have same shape. Same shape is mandatory. It is important. It should have same shape, but not necessarily. That means it is not mandatory that these two triangles should have same size. It can have or it cannot have. It can have same size or it cannot have same size, but it should have the same shape. That one we call it as the similar triangle. So we will understand similar triangles as the class goes on. We'll understand still in a better way. Okay. Coming to one more example, you can see here whether these two triangles are similar or concurrent. So whether this is similar or concurrent, this is similar triangle. It is similar, but it is not concurrent. These two triangles, because we can able to see here it is 10 and 15. 10 by 15. Okay. Here it is 8 and 12. 8 by 12, and here it is 6 and 9, that is 6 by 9. So what we can able to do is, this is in a ratio of 2 by 3, this also it is having a ratio of 2 by 3, this also is having a ratio of 2 by 3. Okay, so this whole triangle, this both these two triangles are in the ratio 2 is to 3. So it is similar. So what we can able to observe, it is having same shape, the shape is same, but but not same size. No, it is not having same size. The dimensions are differing, but the shape is looking same. So it is similar. Okay. So I have a small exercise. Whether this is a concurrent figure or a similar figure. Whether this is a concurrent figure or similar. Concurrent or similar. So the answer is it is a similar figure. It is not a concurrent figure. It is a similar figure because it is having same shape. It is having same shape. The shape is same, but the size is not same. Not same size. Okay, fine. So what is going to be the application in studying this? What is the use of studying this? For example, let us assume there is a mountain. Near your house there is a mountain, and you want to find the height of the mountain. You want to find what is the height. So what you want to do is you want to find the height of the mountain. So and you are standing here. This is your height. Say your height is small h and the mountain height is capital H. And you know what is the distance between you and the mountain. Say the distance is d. So what we can do is by using this similar triangle property, or by applying the property of the similar triangles, I can able to find what is the height of the mountain. There is no need for me to go and measure what is the height of the mountain. If I want to find the height of the mountain and I know your height, the distance between you and the mountain, we can able to find what is the height of the mountain. So in the next video, we'll discuss more about the similar triangles and the similar figures. Okay, thank you.